question. Okay, so I will continue, and if you have any question, whenever you have any question, you can ask your question. You can type your question in the chat box, or you can raise your hand and ask your question. Okay, as we said before, we may have different types of structures in a system. And how should we know that which one of those structures are architectural? A structure is architectural if it can help us to reason about the system and the properties of the system. This reasoning is about attributes of the system, usually the quality attributes of the system that are important to the stakeholders, maybe all of the stakeholders, or maybe a specific stakeholder. So if a structure can help us to reason about quality attributes of a system, and those attributes are important for our stakeholders, then we can call that structure an architectural structure. These attributes are can be including functionality of the system, the functionality that the system achieves and represent to the users, the availability of the system, especially whenever the faults are present in the software, the difficulty of making specific changes to the system, the changeability of the system, the responsiveness of the system to user requests, and many other quality attributes that are important for different types of software system. So if a structure can help you to reason about each one of these attributes, then you can call that structure an architectural structure. Hello, Mr. Majid. Welcome to the class. It's okay. Welcome to the class. And for previous slides, you can watch the recorded video of our today's class. I will record every session, and you can watch the video of that session later. One of the important points about the architecture is that it is an abstraction. An architecture is an abstraction because in an architecture we have software elements and how those elements relate to each other. So in architectures we specifically omit some detailed informations about the elements, especially the internal information about elements that are not useful for reasoning about the system, that are not useful for the architecture of the system. So some of the detailed information about how the element work and how it is implemented internally are not going to be considered when designing the architecture. And we have a goal for that because they don't have any ramifications outside of the element. They are important in the element, but they are not useful for other elements, and they cannot affect the interaction of that element with other elements of the system. So in an architecture we select certain details and we will suppress other details. The private details of elements, the internal details of the elements, the details that are solely having to do with internal implementations are not architectural. So when we are designing the architecture, we don't consider those internal elements. We will omit them and leave them for the next steps. The architecture abstraction is a good thing because it will let us look at the system in terms of its elements and not the details, and we just look at how these elements are arranged and how they can interact with each other and how they are composed, and we can look at their properties and how they can support the system's reasoning. So if we want to consider all the detailed information, we will be confused. We want to just focus on these attributes of the system. This abstraction is essential because it will help us to tame the complexity of an architecture. If we want to consider all the details of the system, then the complexity will be very high. We cannot decide properly. We simply cannot and also do not want to deal with all of the complexity of these elements and their internal implementations. Another important point about the architecture is that every software system has a software architecture, because every system comprises elements and also the relations among those elements. So if we don't even design an architecture for a system and just go and implement that system, after that we can recognize the architecture of that system. So even if the architecture is not known to anyone, the architecture the architecture of that system exists. So perhaps all of the people who designed the system are long gone, or maybe the documentation have been vanished, or maybe the producers, the developers, don't even produce any documentation. They didn't document the system, or maybe the source code has been lost, or in softwares that we don't deliver the source code, so the source code was never delivered. In all of those systems, we have a software architecture. We always can distinguish the software architecture of any system. An architecture can exist independently of its description or specification, and because of that, documentation is a critical part of the software development, especially for designing a software. Okay, there are one other point. I will talk about this other point, and then if you have any question, you can ask your question. The other important point about the architecture is that it includes behavior. The behavior of elements can impact the architecture of the system. So the behavior of each element is part of the architecture, and also the behavior of those elements can be useful to reason about the system.